In this video, we're going to be talking about the divergence test. So to cover what the divergence test is, we're going to consider some series, and we'll call that series A sub n. And the divergence test states that if the limit of just the sequence part of that series is not 0, then the series diverges. And the most important thing that I would like to highlight several times is that the divergence test cannot tell you that a series converges. So think about that for a second. The divergence test can only conclude divergence. So essentially, when we apply this test to a series, we will come up to the conclusion that a series diverges, or we'll come to the conclusion that we simply don't know what the series does. Let's take a look at some examples. We're going to first use the divergence test to determine whether the series diverges or whether we need more information or tools. And we'll start with the series n over 3n minus 1, and we're going from 1 to infinity for our indices. Okay, so applying the divergence test, we take a look at the limit of the sequence, and we've got n over 3n minus 1. L'Hopital's would work. Another strategy, which I think is a bit quicker, is if we factor out the n from the numerator and the denominator, reduce the n, and then push the limit through so that we're left with 1 over 3 minus the limit as n goes to infinity of 1 over n, and well, that limit is 0, so we end up getting 1 over 3 minus 0, which is 1/3. So 1/3 is not 0, obviously. So by the divergence test, our series diverges. So until you're fully in the habit, make sure that with this last sentence you use a little bit more words, because you want to make sure that your logic makes sense to yourself before you leave that particular series, right? So if you're saying things in your conclusion like, by the divergence test, this series converges, if you read that back, hopefully it should feel suspicious. And if you state things like, okay, because I got a non-zero limit by the divergence test, you're kind of stating the criteria and the result of the theorem, and it helps you catch that you're using the theorems correctly, basically. So that's why I kind of say, okay, the obvious 1/3 is non-zero, but that helps remind me of what the criteria for the divergence test is. Okay, let's take a look at another example. So for our second example, we'll be determining whether the series 1 over n cubed converges or diverges. And looking at the divergence test, we'll take the limit as n goes to infinity of 1 over n cubed, which is 0. Okay, so by the divergence test, we just don't have any information. Okay, because all the divergence test can tell you is whether something diverges. So whether the series converges or diverges, we do not know based on the divergence test. We have, as a matter of fact, seen this series in, or rather, apologies, we will see this series in upcoming videos about certain types of series. So for now, we don't have information. Okay, so for part C, we have e to the 1 over n squared as our series, ranging from 1 to infinity, and we'll take a look at the limit as n goes to infinity of e to the 1 over n squared. Pushing my limit through, that is e to the limit as n goes to infinity of 1 over n squared, which is e to the 0, which is 1. So by the divergence test, our series diverges because we got a non-zero limit for the sequence terms. Fairly straightforward. The divergence test is probably the first test that you'll be mentally applying to every series when you see it. In upcoming videos, we'll get more information that gives us the ability to deal with a lot more series than the divergence test. So I'll see you then.